Hashtag remote rocks. Week 2. Circles. Fancy video editing, huh? So, welcome back, week 2. Hopefully week 1 went relatively smoothly for you guys. I know there was a lot thrown at you guys, and hopefully you were able to manage things, figure out a schedule that works for you. If you're ever struggling with things, please reach out to us. Remember, we're all in this together. We're always here for you guys. So first and foremost, hopefully you guys are staying healthy, staying safe, and then most importantly, just having fun and staying happy. I know this is a trying time for a lot of us, and most importantly is just your health and making sure that you're keeping your spirits high. We'd love to hear what you've been doing with your time and outside of staring at a screen and doing school. So I know for us, my wife convinced me to get a Nintendo Switch, and so we've been playing a lot of Animal Crossing. Not sure of the point of the game, but hey, it's fun. It's a way to spend some time together. So we'd love to hear from you guys. Reach out to us, jump onto our office hours, and let us know. So anyways, before we get back to our content beginning of the week, so we got some riddles here. All right, first one. A word I know, 6 letters it contains, subtract just 1, and 12 is what remains. What's the word? In 3, 2, 1, the word is dozens. Take away 1 letter, it becomes dozen. 12. Gotcha. All right, second one. What begins with T, ends with T, and has T in it? Answers in 3, 2, 1. Answer is teapot. Get it? Because it has T in it. All right, and last one. This one's a little tricky. What is the minimum amount of cuts needed to make? What is the minimum amount of cuts needed to a cake to make 8 equal slices? Answers in 3, 2, 1. The answer is actually 3. I was thinking 4, but apparently the answer is indeed 3. Try to figure that out. Let me know, because I'm still not sure about that one. Yeah. Anyways, hopefully you were able to watch our week 1 videos, get those quick checks done, get that assessment done. If you haven't done so yet, please make sure that you're keeping up with this stuff. And we're pushing this stuff out so you have a whole week to do it. You can set your own timeline when to do it, but if you put these off, then things are just going to start to pile up on you, and we don't want that. We want things to be low stress, and then pretty easy if you can just schedule your time out. Again, if you need help, please reach out to us. We are here to help you. But let's go ahead and take a look at what we're getting into this week. So we're still working on our circles, but we're switching away from arc length and sector area, and we're looking at 3 new standards here. All right, so our 3 standards. First one, determine the measures of angles and arcs in circles. Okay, so that's what we're going to look in this video. And then our second video is we're going to look at determining the relationships between central angles, inscribed angles, and their intercepted arcs. And then one more video, determine the relationships between arcs and chords. Now, some more vocab in there. A lot of that you probably have seen before, but we will talk about the stuff that you haven't. So, in order to do that, again, we need to look at some vocabulary. Now, in last week's videos, we talked about arcs. Remember, arcs are a part of a circle between 2 endpoints. So I like to think it's the crust of your pizza. No matter how big or how small your slice is, you always have an arc. Now, in this picture, we have minor arcs, major arcs, and semicircles. I remember a minor arc is an arc that is less than 180 degrees. Okay. A major arc is an arc that is greater than 180 degrees, and a semicircle is an arc that is equal to 180 degrees. So if you look at our picture here, you have this orange arc from P to R. That is a minor arc. because we know it's less than 180 degrees. You have this green arc, it's going from P to R, but the opposite way, that is a major arc. And we know that because it's greater than 180 degrees. Then if you just look at the arc from P to T, you know that that is a semicircle because it's half of your circle. So just keep that in mind. Now, when we're talking arcs, remember from last week, we also talk about what we call the central angle. Now, we just threw that out at you last week, but let's define that. So a central angle is an angle with a vertex at the center, hence central, and radii as the sides. So if you think about our picture here, we have multiple central angles. We could say P, Q, T, that is a central angle. It's a vertex at the center, and then PQ and TQ are your radii. So that is your angle, your central angle. Now, when we talk about those central angles, they also correspond with your arcs, so it corresponds with RPT. That completes your sector from last week. Now, what we're going to be talking about today in this video is arc measure. Now, last week we talked about arc length. That was your distance between two endpoints of an arc measured in linear units. So if I were to take a tape measure and measure from A to B, and that's 72 inches. That's our arc length. Okay. And this week, we're talking about the arc measure. We mentioned this last week, but it's something we don't want to get confused with arc length. Arc measure corresponds and is equal to the measure of the central angle. So in this case, our central angle is 110 degrees, and the measure of arc AC, okay, so the measure of arc AC is also 110 degrees. Now, why do we care about that, or where does that come from? Why do we talk about the arc measure? Well, I was thinking about an angle, it's how much we turn. So if I was standing at B, okay, and I looked from A to C, I am turning 110 degrees. Well, it's the same no matter where you are on the circle. So if I'm standing at A, then I'm facing this way. If I travel along the circle to point C, then I'm not facing this way. Well, how many degrees have I turned? I have turned 110 degrees. Okay, so it's all a relative to your position. That's why we talk about the arc measure. Now, it's really as simple as that. If I know the central angle, then I also know the arc measure. Okay, so let's think about this guy. Okay, so I want to determine the value of x and then the measure of each arc. So we could give you a problem like this, and we want to find, okay, first of all, what is this x value? So the remaining central angle, and then what are the values of each of those 1, 2, 3, 4 arcs, the measures of those arcs. So first of all, let's figure out what is this angle here, this central angle. Well, we know the whole circle, all of these central angles added up together would be 360. So I can take away the 85, the 40, and the 90. If I do that, then I end up with, let me subtract those, 145 degrees. Okay, so then I know that. Now, before I even look at what are we trying to solve for, okay, I can take these guys and I can figure out, okay, if I know the central angle here, then the intercepted arc is the arc that it is eating here. And I know that is equal to that central angle. So this would be 85 degrees. Okay, same thing all the way around. If this is 40 degrees, then I know that this arc is 40 degrees. Okay, if this is 90 degrees here, then I know from B to E, that's 90 degrees. And the last but not least, from D to E, again, that would be 145. So let's go ahead and fill these guys in. So X would be 145 degrees. Okay, the measure of arc BC. Now keep in mind, when we talk about the measure, we want to keep this M here. Okay, because if we leave that off, then we don't know if we're talking arc measure or arc length. In this case, we know we're talking arc measure. So we're looking at BC, which is 40 degrees. If I look at CD, that's 85 degrees. from D to E, that was 145. And last but not least, E to B was 90. Now, if I add all of those up, I should see that they equal 360 degrees. Because again, if I start from B and I go all the way around the circle, I should have turned 360 degrees to face the same way. Okay, so let's look at one more example here. So in this case, it says PM is a diameter of circle R, and I want to determine the following values. Now, what I will tell you in a lot of these pictures, okay, it won't explicitly tell you that we have a diameter. Sometimes it will, sometimes it won't. Most of the time you can assume, okay, if it looks like it's a straight line from P to M, that is a diameter if it goes through the center. Okay. Well, why is that Q? That tells us, well, that's half of our circle. So I have a semicircle in here. So let's think about what values could I fill in. Now, again, before I even look at what values, let's go ahead and fill in what we know. So we know this is a 90-degree angle, right? Which then means since this is a diameter, this guy would also be 90 degrees. So angle NRM. Okay. So then we know that this arc measure is 115. So that tells us the central angle is also 115. All right. Now going back all the way to first quarter, if this is a diameter, which is 180 degrees, let's think about these two angles here and here. Those are what we call supplementary. So they add up to 180. So if I subtract 115 from 180, I end up with 65 degrees. Now, since we know each of the central angles, we know the measures of each of the corresponding arcs. So I could fill this out. Arc NP measures 90 degrees, NM is 90 degrees, and MQ is 65 degrees. Right? So when we go through these problems, and I know when Mr. Sutherland works through these, he likes to just fill out everything that we can possibly fill out, and then we can go back to the problem and see, okay, what are we actually looking for? Okay, so now this is asking for the measure of arc N or MN. So that is this guy. Well, we filled that out. That is 90 degrees. Okay. Now we're looking for the measure of arc NQ. Well, that is from N all the way to Q. Now, if you recall back from first quarter, if I have two parts, part plus part equals a whole. And that's our angle addition, our segment addition postulate. Well, we have an arc addition postulate where we could just add these together as well. So I have 90 plus 65. So that gives us 155 degrees. Okay, so I just add up the pieces. All right, so now I'm looking for the measure of angle PRQ. So that is from P to R to Q. So that angle there we figured out was 115 degrees. And last but not least, I want the measure of arc QM or QNP. Now, keep in mind, when we have three letters, okay, that's going to give you a hint of that's your what we call our major arc. And that's the arc that goes the long way around. So I go from Q through N. Whoop, let me get that. All the way to P, so your major arc. Okay. Now, the reason why we named that with three letters, because if I just said QP, well, then that would be talking about that guy there. Okay, so adding that N tells us I want the major arc, so I add up the 90 plus 90 plus the 65, and I end up with 245 degrees. Okay. All right, so again, big picture here is the central angle is equal to the measure of the arc, and now I can just add up pieces if I need to look for bigger pieces. All right, so now one more slide here. We had a question on a quick check last week where we said, I want to know what is the central angles of each of the pieces of a pie chart. Now, most of you guys figured that out, but if you weren't able to or it didn't really make any sense, let's think about this guy. So I have a survey of kids in sports, and it says 22% of the kids play football, 21% play soccer, 17% play basketball, and so on and so forth. We want to know what is the angle measure right here, that central angle, which then would also give us the measure of this arc. Well, if I have 22% of the circle, remember the whole circle is 360 degrees. So I take 360 degrees and 22% would be 0.22. So I just multiply. I'm taking 22% of 360, and that gives us 79.2. And that would be our central angle. Okay, and I could do that for each of the slices of pies. Okay, and then once I get all of those 1, 2, 3, 4, 5, 6 sections, I should be able to add them up, and they should add up to 360. Okay, I will let you do the rest of those on your own if you feel so inclined, but it's the same method for each of those slices. All right, so now that we know our central angles, okay, if you're comfortable with figuring those things out, we can move on to our next video. And our next video will be talking about other angles within our circles. So again, if you feel like you're ready, you can move on. If you feel like you need a little extra help, please jump onto our office hours. Remember, Mr. Sutherland is from 9:30 to 10:30. I am from 1:30 to 2:30. And you can reach us through email anytime throughout the day. Just send us a quick little note and we will get back to you. One quick note, if you do want to attend those office hours, please sign up just so we're aware of who's coming. If we don't see anybody signed up, then we have some other things that we can take care of. But if we know that somebody's there, then we will jump on and we will make sure that we are available for you. Okay. Again, hopefully you guys are staying safe, staying healthy. Hope to see you guys soon. All right.